Good morning, everyone, and thank you for being here today. I am Dr. S.K. Singh, and I'm excited to present to you on the topic Selection of Mobile Phase in Hplc Analysis. Today, we will explore how choosing the right mobile phase is crucial for effective Hplc analysis. We'll cover the key factors involved and some practical considerations. So, let's get started and delve into this important aspect of chromatographic techniques. The mobile phase in high-performance liquid chromatography, or Hplc, is really central to how the separation works. Think of it as the liquid solvent that carries the analytes through the column. It interacts with the stationary phase, which helps separate the different components. The properties of the mobile phase directly affect key aspects like retention time, resolution, and how well we can distinguish between compounds, what we call selectivity, as well as the shape of the peaks we see in our chromatogram. By adjusting the composition, say, changing the amount of water, methanol, or acetonitrile, we can control the strength of the mobile phase. A stronger solvent will usually reduce retention time, meaning compounds pass through faster, while a weaker solvent tends to increase separation, giving us better resolution. It's also important to consider the pH and buffer system of the mobile phase. These factors help control the ionization of analytes, which in turn affects how they interact with the column. This control can improve peak symmetry and overall accuracy. And don't forget about additives like acids. They can really enhance separation and make our results more reproducible. So, in summary, adjusting the mobile phase carefully allows us to fine-tune the entire separation process, making Hplc a powerful and versatile tool in analytical chemistry. Let's take a look at the different types of mobile phases used in chromatography. First, there's the reverse phase, or rPHPLC. In this mode, we typically use polar solvents like water, methanol, or acetonitrile. These solvents are key because they interact differently with the analytes compared to the stationary phase, allowing us to separate compounds based on their polarity. On the other hand, we have the normal phase, or NPHPLC. This mode uses nonpolar solvents such as hexane or chloroform. Here, the separation relies on the difference in polarity between the analytes and the stationary phase, which is usually polar. We also have some special modes, like ion pairing and buffer systems, which help us handle more complex samples or improve separation under certain conditions. Now, the mobile phase itself plays a crucial role in chromatography. It interacts with both the analyte and the stationary phase, which is what makes the separation possible. It controls several important parameters, including retention time, the time it takes for a compound to pass through the system, and peak shape, which affects how clearly we can distinguish different analytes. It also influences the selectivity, meaning how well the method can differentiate between similar compounds, and the resolution, which is about how sharply separated the peaks are. By adjusting the mobile phase composition, we can fine-tune these factors to optimize our separation process. Now, let's move on to additives in the mobile phase. These additives play a crucial role in improving the separation and the shape of the peaks we observe during analysis. For example, formic acid is commonly used, especially because it helps with ionization in mass spectrometry. Another important additive is trifluoroacetic acid, or TFA, which is frequently used in peptide analysis to enhance peak sharpness and reproducibility. Next, I want to highlight the importance of buffers in the mobile phase. Buffers are essential because they help us maintain a stable pH throughout the process. This stability is key to achieving consistent and reliable results. Some common buffers include phosphate buffer and acetate buffer. For instance, adding 0.1% phosphoric acid can significantly improve reproducibility, ensuring that our results are consistent from run to run. Finally, these components, additives and buffers, are integral to fine-tuning the mobile phase, making sure we get the best possible separation and peak quality, which ultimately supports the overall accuracy and reliability of our analysis. Let's talk about elution strength, which is essentially the ability of a solvent to move analytes through the column. A stronger solvent will result in faster elution, meaning the analytes will come out of the column more quickly. For example, if we increase the percentage of acetonitrile in the solvent mixture, you'll notice that the retention time decreases, so the analytes pass through faster. Now, when choosing solvents, there are some common ones we use, each with different properties. Water has high polarity, making it useful for polar compounds. Methanol has moderate polarity, and acetonitrile is known for its low viscosity and strong elution strength. In fact, a typical reverse phase Hplc system often uses a mixture of water and acetonitrile to optimize separation. When selecting a solvent, we also need to consider key properties like polarity, UV transparency, which is important for detection purposes, viscosity, which affects the pressure within the system, and miscibility, meaning how well the solvents mix together. For instance, acetonitrile is often preferred over methanol because it produces lower back pressure, making the system run more smoothly and efficiently. Understanding these factors helps us fine-tune our chromatography method to achieve better separation, faster runs, and more reliable results. Let's talk about the solvent selection strategy. First, we need to identify the properties of our analyte, such as its polarity and pKa. Understanding these characteristics helps us choose the most suitable solvent system, which typically involves a combination of water and an organic solvent. Once we've selected the initial solvents, we may need to adjust the pH and buffer conditions to improve separation. Next, it's important to optimize the ratio of solvents through trial runs. This helps us find the best balance for effective elution. Speaking of elution, the elution strength is a key concept here. It refers to the ability of the solvent to carry analytes through the column. Generally, a stronger solvent results in faster elution times. For example, increasing the percentage of acetonitrile in our solvent mix will decrease the retention time of our analytes, making the separation quicker. And of course, solvent choice can be expanded further, as different solvents have different strengths and effects on the separation process. Overall, selecting and adjusting the right solvent system is crucial for optimizing our chromatography performance and achieving clear, efficient separations. Now, let's talk about pH control in the mobile phase and why it's so important. The pH of your mobile phase can significantly affect the ionization of your analytes, which in turn influences their retention and detection. Typically, when working with silica columns, you want to keep the pH between 2 and 8 to ensure optimal performance and stability. For example, if you're analyzing basic drugs, you might use an acidic mobile phase. This helps improve the peak shape, making your results cleaner and more reliable. Next, I want to touch on the difference between isocratic and gradient elution. Isocratic means the mobile phase composition stays constant throughout the run. It's simple and great for analyzing samples with similar properties. On the other hand, gradient elution involves changing the mobile phase composition over time. For instance, gradually increasing the percentage of acetonitrile from 10% up to 90%. This approach is especially useful when separating complex mixtures, as it helps achieve better separation efficiency and reduces analysis time. Overall, understanding how to control pH and choose the right elution method is key to optimizing your chromatography results and ensuring accurate, high-quality data. Now, let's take a closer look at protein analysis. When working with proteins, we typically use a mobile phase composed of water, acetonitrile, and a small amount of TFA, which is 0.1%. This combination helps in effectively separating the proteins or peptides. We often apply gradient elution, gradually changing the solvent composition during the run. This approach allows us to achieve efficient separation of peptides, which is crucial for accurate analysis. Moving on to the case study on pharmaceutical analysis, here we're looking at analyzing compounds like paracetamol and caffeine. In this case, the mobile phase is a mixture of water and methanol in a 60-40 ratio. This setup provides good resolution and peak symmetry, meaning the peaks are well-defined and easy to distinguish. Overall, these techniques highlight how careful selection of mobile phases and elution strategies are key to achieving precise separation, whether we're analyzing proteins or pharmaceutical compounds. This consistency in approach helps us obtain reliable, high-quality data across different applications. So, as we wrap up, I want to emphasize that the choice of the mobile phase is absolutely crucial for achieving optimal HPLC performance. The key factors we need to consider include the type of solvent we select, because it directly influences the separation efficiency. Then, there's the pH and the buffers we use. These can dramatically affect how compounds interact with the stationary phase. Next, the elution method plays a significant role, whether it's isocratic or gradient, as it impacts the resolution and analysis time. And of course, proper optimization of all these parameters is essential to obtain accurate and reproducible results. Ultimately, paying close attention to these details ensures that our HPLC runs are reliable and meaningful, supporting the overall goal of precise chemical analysis. For further support, please don't hesitate to reach out to us. We're here to help with any questions or additional information you might need. Remember, your success is our priority, and we're glad to assist you whenever necessary. Thank you so much for your time and attention today. We truly appreciate your engagement and look forward to staying connected.